All right, today we are going to be practicing drawing parallelograms. One thing we noticed when we were drawing triangles is that we had some floating triangles. And so we want to make sure with our parallelograms we don't have floating parallelograms. And what I mean by that is your corners of your parallelograms and your side lengths don't match up with the grid lines of our grid paper. So this parallelogram is floating. Our corners do not match up with a corner of our grid papers. And our base here does not line up with our grid paper. So this is something that we do not want, okay? Big ol' X through that. However, what we do want is parallelograms that have their vertexes and their base and top base on the grid lines. In order to do that, we have to start with our corners or our vertexes. So what I'm going to do is I'm going to start with my corners or vertexes by putting a dot right on the vertex. And if I need or I want a base that is, let's say, 4. 1, 2, 3, 4. Then I know my end of my base has to be there. Now I can connect. And now my base is right on that grid line and my corners are on the corner of my grid paper. And then again, I need my top base to be 4. Now I'm just going to scoot it over 1 segment or centimeter. I need my top base to also be 4 centimeters. And then I can just go ahead and with a ruler, draw in my other side lengths. This is a phenomenal parallelogram. My corners match up with the corners of the grid paper. My top base and my bottom base line up right on the grid lines. And it is not floating. Big thumbs up to that one. All right, so now that we know how to draw a correct parallelogram, we are going to have to work with sometimes something called a constraint. And a constraint means that we might be given what our base is, or we might be given the height. So in this case, we're going to practice drawing a parallelogram with constraints of a base of 5 and a height of 3. So now I have to draw a parallelogram with a base of 5 and a height of 3. So I'm going to go ahead and draw my base. I'm going to start on a corner, and then I'm going to count 5 segments, and then the end of my segment here, and connect. So there is my bottom base of 5. And now I need a height of 3. So now I know my height has to go up 3 to this grid line. But that would be a perfect rectangle. So I'm going to go ahead and scoot my top base over 1 column. And then I need to create a top base, again, of 5. And I'll end it there. So now I have a top base of 5. And then all I have to do is connect my corners or my vertices. So when I get rid of this, I will have a parallelogram with a base of 5. Whoops. Here, I got that, and I have a height of 3. I got that. Now, they might ask you, can you make another parallelogram with the same constraints? Also a base of 5 and also a height of 3. Well, let's go ahead and try it. I'm going to create my bottom base, 1, 2, 3, 4, 5. And I'm going to connect that line segment. Now I know I need a height of 3, so I need to be up working with this grid line. And the last time I moved over 1, so this time I'm going to move over another one. And I'm going to start my top base here. Again, I need it to be a top base of 5. And I'll end at the line segment here. 1, 2, 3, 4, 5. And now again, I just connect my vertices. So when I get rid of all this extra, I have a different parallelogram. I still have a base of 5, and I still have a height of 3, but it's a little more slanted than my previous one. Now, can I make another one? I think we can. This time, I'm going to make my base starting here. I'm going to create my first vertice, and then I'm going to go over 5. I still need a base of 5. And I need my height of 3. And last time, we both tried to go over 1 here. We went over another one here. And this time, I'm going to mix it up. I'm going to go this way. So I'm going to actually create my first point of my top base over here. And I'm going to get rid of all this. And now I'm still going to keep a top base of 5. 1, 2, 3, 4, 5. And I'm going to connect that line segment. And really all I did is I just bumped my parallelogram the opposite way. So let's check. I need a base of 5, which I have, and a height of 3, which I still have. All right, finally, last but not least, I need a 4th parallelogram that has these same constraints. So I'm going to start here, create my base of 5, and my height of 3. So I'm needing to work with this grid line. I'm going to come all the way over here, just for fun. I still need a top base of 5. Connect my top base line segment, and then I need to connect my vertices. There's one slanted parallelogram, but if we check, I still have a base of 5, and I still have a height of 3. Now, when I have a slanted parallelogram like this, I can find the height inside the parallelogram like I did here, or I can find one of my top vertices and draw a line down to match up with the bottom base. And this is another place where I could find my height of 3. Because now we're noticing, I have a rectangle right here. Still with a base of 5 and a height of 3. So now, if we go back, we can see I have created 1, 2, 3, and 4 different parallelograms that all had the same constraints of a base of 5 and a height of 3.